Okay, let's try manipulating Maclaurin series. And so with Maclaurin series, one thing we can do is term by term integration. Okay. So if I start off with something like this would be the sum n equals 0 to infinity of, well, x to the n. We already investigated this problem. We determined its radius and interval of convergence just a minute ago. All right. Now, what if I wanted to manipulate this problem? Okay. What if I said, okay, all right. Okay, so I can manipulate the problem in this way. And what is another way to write this? Is 1 divided by 1 plus x squared. So the antiderivative of 1 divided by 1 plus x squared with respect to x would equal, now the sum, n equals 0 to infinity, let's put that interval sign out there, of negative 1 to the n, x to the 2n, and this is going to be an integral with respect to x. Okay. Well, the integral of 1 divided by 1 plus x squared is tangent inverse of x, which will equal, now the sum, n equals 0 to infinity of negative 1 to the n, then x to the 2n plus 1 divided by 2n plus 1. Okay, and now we can ask ourselves, where does this thing converge? When is this true? That the inverse of tangent is the sum n equals 0 to infinity of negative 1 to the n x to the 2n plus 1 divided by 2n plus 1. Huh. So we can say, okay. So we're asking that after integrating, all right, so what did we do on this problem? We manipulated the geometric series to make it look like the derivative of tangent inverse, okay? And then we said, okay, 1 divided by 1 plus x squared, if I integrate that, I'm going to get tangent inverse of x, okay? And so I integrated both sides of the problem, and when you integrate all of these polynomial parts of the problem, what are you going to get? It's just going to go up by 1 and divide by that number, okay? And so now we have the tangent inverse of x is equal to this infinite series, but we still have to ask ourselves the question of, where is this true? What is the interval of convergence that this infinite series right here actually converges to tangent inverse of x? And to do that, we will do the ratio test. And so, ratio test. We're going to have the limit as n tends towards infinity. The absolute value, that's going to be negative 1 to the n plus 1, x to the 2n plus 3, divided by 2n plus 3, and then multiplied, and let's close those parentheses. 2n plus 1, and then that would be negative 1 to the n, x to the 2n plus 1, okay? And so that'll give us x squared times 2n plus 1 divided by 2n plus 3. Sorry, there's a limit right there. Okay. And then we can divide by the highest power on top and bottom. And that'll equal the limit as n tends towards infinity of x squared times 2 plus 1 divided by n divided by 2 plus 3 divided by n. And we can just say that this is x squared has to be less than 1, okay? Or if we want to investigate, write this as an inequality. If x squared is less than 1, the negative 1 is going to be less than x, which is going to be less than 1. And so we need to check x which equals negative 1 and x which equals 1. Okay. Let's start with positive 1. So, if x equals 1, we end up with the sum n equals 0 to infinity of negative 1 to the n divided by 2n plus 1. All right. Now, the easiest way to do this is just going to be to do the alternating series test. Now, 1 divided by 2n plus 3 is less than 1 divided by 2n plus 1, that's true. And the limit as n tends towards infinity of 1 divided by 2n plus 1 equals 0. So x which equals 1 is convergent by alternating series test. Okay, now why is this important that x which equals 1 is convergent by the alternating series test? Okay, this is actually a very important state of convergence. Okay, the reason that this is an important place when considering convergence has to do with this. So why is this point so important right here? Okay, so tangent inverse of 1 will equal, okay, so if I plug 0 into this, I'm going to get 1 minus 1 divided by 3 plus 1 divided by 5 minus 1 divided by 7 plus dot, 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 like that. What is tangent inverse of 1 is pi over 4 equals 1 minus 1/3 plus 1 divided by 5 minus 1 divided by 7 plus dot, 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 like that. And so pi, the number itself, actually equals 4, and then multiplied by 1 minus 1/3 plus 1 divided by 5 minus 1 divided by 7 plus dot, 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 like that. And so the fact that this Maclaurin series converges to tangent inverse at 1, and that tangent inverse of 1 is pi over 4, that gives us a method for calculating pi. And so when people talk about pi, they talk about an infinite non-repeating decimal. Just because something is an infinite non-repeating decimal, does that mean that patterns absolutely do not appear within it? No, there's a pattern that is going on right here that actually allows me to calculate pi. All right, now we still need to check the other point. All right, now if I plug in x, which equals -1, we have the sum n equals 0 to infinity of -1 to the n, now -1 to the 2n plus 1 divided by 2n plus 1. Now -1 to the 2n plus 1, what is that going to be? That's going to be -1, the -1 cubed, the -1 to the 5th, -1 to the 7th, like that. It's always negative. And so this would equal the negative of the sum n equals 0 to infinity of -1 to the n divided by 2n plus 1, okay? This is convergent from the first part, okay, because this is just the negative of that. And so what does this one actually converges to? This is going to equal now negative pi over 4, okay? So the interval of convergence would be -1 is less than or equal to x, which is less than or equal to 1. So it's going to include both endpoints for the convergence of this Maclaurin series.